What if we're not the universe's first children, but merely latecomers to a cosmic party that began billions of years ago? Imagine standing on a quiet hill under a starry sky, gazing up at countless points of light, each one a sun like our own. We often feel alone in this vast cosmic ocean, believing humanity represents the pinnacle of intelligence the universe has produced. But what if that's simply not true? What if, long before Earth even formed, ancient civilizations rose and fell among those distant stars, leaving behind echoes of their existence that we're only now beginning to detect? This isn't just science fiction, it's a possibility that leading astronomers, physicists, and cosmologists are taking seriously as we push the boundaries of our understanding about life's potential in the cosmos. Today, we're embarking on an extraordinary journey through 30 compelling theories about the universe's first intelligent life. We'll explore everything from rigorous scientific hypotheses to mind-expanding speculative ideas that challenge everything we think we know about our place in the cosmic story. These aren't just random guesses. Each theory represents a fascinating thread in the tapestry of cosmic possibility, grounded in our growing understanding of physics, chemistry, and the fundamental conditions that might give rise to consciousness. Some suggest intelligent life could have emerged within the first few billion years after the Big Bang, when the universe was dramatically different than it is today. Others propose that we might be living in a cosmic ruinscape, surrounded by the artifacts and remnants of civilizations that flourished when our solar system was just stardust waiting to coalesce. As we dive into these 30 theories, you'll discover why the search for cosmic ancestors represents one of the most profound quests in human history. This exploration touches on the deepest questions about existence itself. Are we unique? Are we alone? Or are we simply the newest residents in a neighborhood that has seen countless generations come and go? Each theory we'll examine offers a different perspective on when, where, and how intelligence might have first sparked in the universe and what that means for us today. So settle in and open your mind to possibilities that will stretch your imagination to its limits. The story we're about to uncover might just change how you see the night sky forever, transforming those distant points of light from anonymous stars into potential homes for beings whose stories began long before ours ever could. Our journey begins with perhaps the most famous and controversial idea about early cosmic intelligence, the ancient astronaut theory. This concept, widely popularized by Swiss author Erich von Däniken in the late 1960s, proposes that extraterrestrial beings visited Earth thousands of years ago and directly intervened in human development. Proponents of this theory suggest that many of humanity's greatest ancient achievements, from the construction of massive pyramids to the sudden leap in our technological understanding, might not be solely our own doing, but could instead be the result of contact with a far older, advanced interstellar civilization. They point to various archaeological mysteries as potential evidence. The precise engineering of the Great Pyramid of Giza, for instance, with its massive stone blocks aligned to true north with astonishing accuracy, raises questions about how such a feat was accomplished with the technology of the time. Similarly, the Nazca lines in Peru, enormous geoglyphs etched into the desert floor that are only fully visible from high above, are often cited as possible landing markers or signals for aerial visitors. Ancient art and texts also come under scrutiny. Cave paintings from across the globe that appear to depict humanoid figures wearing strange suits or helmets, or objects hovering in the sky, are interpreted by some as literal records of alien encounters. Even religious scriptures are re-examined through this lens, with stories of prophets being taken up to heaven in fiery chariots or gods descending from the stars seen as possible distorted accounts of actual events involving advanced spacecraft. It is crucial, however, to understand the significant skepticism this theory faces from the mainstream scientific and archaeological communities. most experts argue that these interpretations undervalue the ingenuity and capabilities of ancient human cultures. The construction of the pyramids, while impressive, is well within the demonstrated capabilities of ancient Egyptian engineering and organization. The Nazca lines likely held cultural and spiritual significance for the people who created them, meant for their deities in the sky rather than extraterrestrial pilots. What some see as spacesuits in ancient art could simply represent shamanic ritual wear or symbolic imagery. The scientific method demands evidence that can be tested and verified, and the ancient astronaut theory often relies on speculative connections rather than concrete proof. Despite this criticism, the theory's enduring popularity speaks to a deeper, almost universal human curiosity about our origins and a willingness to consider that our story might be far more incredible and far more connected to the cosmos than we ever previously imagined. Moving beyond the realm of ancient intervention, we arrive at a theory grounded more firmly in established science, yet one that is equally staggering in its implications. This is the Panspermia hypothesis, the compelling idea that life's building blocks, or even life itself, is not confined to a single planet but is a cosmic traveler, hitching rides between worlds on asteroids, comets, and interstellar dust. If this is true, it radically reshapes our search for the universe's first intelligent life, suggesting that the spark of consciousness may have ignited on a single, long-lost world only to be scattered like cosmic seeds across the galaxy, potentially making many planets heirs to a common biological heritage. The mechanics of this interstellar seeding are both fascinating and surprisingly robust. We know that certain extremophile microorganisms on Earth are incredibly tough, capable of surviving in the vacuum of space, enduring intense radiation, and withstanding temperatures near absolute zero. Experiments on the International Space Station have confirmed that clumps of bacteria and other microbes can survive for years on the exterior of a spacecraft, shielded within the nooks of a rock. Now, imagine a massive asteroid impact on a life-bearing world. Such an event could easily eject tons of microbe-laden debris into space. These tiny biological capsules would then be set adrift on cosmic currents, traveling for millions of years within their protective rocky shells. When their journey finally intersects with a promising new world, a young planet with liquid water and a stable atmosphere, they crash land, potentially introducing life to a virgin environment. This process doesn't require advanced technology or intelligent design. It's a natural, albeit violent, mechanism of distribution that the universe performs automatically. This concept elevates our search from simply looking for other islands of life to considering the possibility of a vast, interconnected archipelago of biology. The first intelligent life may not have emerged on a temperate, Earth-like world as we often picture. It could have developed on a planet orbiting one of the universe's first generation of stars, a place with a completely different biochemistry and environment than our own. After achieving sentience, that civilization's ultimate fate is a mystery. They could have transcended, collapsed, or been wiped out by a cosmic catastrophe. But before their end, a random impact event could have catapulted their planet's microbial legacy into the void. Those dormant biological packages would then become the universe's messengers, carrying the potential for intelligence across light years of space and billions of years of time. We and every other complex life form we might ever discover could therefore be the distant descendants of that single, ancient Genesis event. Our entire evolutionary path, from the first single-celled organism to our pondering of the cosmos, might be the unfolding of a biological program that began on a world we will never identify, making the search for our cosmic ancestors the greatest detective story in history. This brings us to a theory that pushes the boundaries of cosmic chronology to their absolute limit. It's called the Firstborn civilization theory, and it posits that the universe's very first intelligent species could have emerged during a primordial habitable epoch, a brief, fiery window just a few 100 million years after the Big Bang. To grasp this, we must abandon our Earth-centric view of a habitable zone around a stable, sun-like star. The early universe was an entirely different kind of nursery, one that might have cradled life in ways we are only beginning to comprehend. Back then, the cosmos was a much denser, warmer place. The first stars, known as population 3 stars, were behemoths, hundreds of times more massive than our Sun. They burned ferociously bright and died young in spectacular supernova, seeding the universe with the first heavy elements essential for planet formation and potentially life. But here's the revolutionary idea: a planet itself might not have been necessary. Astronomers like Abraham Loeb at Harvard University have proposed that in that early, warm universe, even free-floating objects, rogue planets ejected from their solar systems or large bodies in gas clouds, could have maintained liquid water on their surfaces, heated from within by geological activity or the residual warmth of the universe's creation, rather than by the light of a star. These dark, nomadic worlds adrift in the cosmic void could have served as the first cradles for biochemistry. Imagine the form life might have taken in such an environment. Without light from a sun, photosynthesis would be impossible. Life would likely be chemosynthetic, drawing energy from hydrothermal vents or radioactive decay in the planet's core, much like the extremophiles found at the bottom of Earth's oceans. Evolution on a world with a thick, insulating atmosphere of hydrogen or methane, under a sky permanently black yet warmed by the background radiation of the young cosmos, would follow a path utterly alien to our own. Sensory organs for sight might be useless, replaced by exquisite sensitivity to pressure, vibration, or chemical gradients. Their entire perception of reality, their conception of the universe, would be built from a completely different set of physical inputs. Now consider the timeline. If such a civilization arose even 1 billion years after the Big Bang, they would have had a head start of over 12 billion years on us. What could our intelligence achieve with that unimaginable span of time? Their technological advancement wouldn't be a linear progression. It would be an exponential ascent into capabilities that border on magic from our perspective. They might have mastered astrophysics to the point of engineering stars or avoiding stellar death, perhaps even learning to harness the energy of black holes. Their understanding of reality might have allowed them to manipulate spacetime itself, creating wormholes for travel or accessing other dimensions. After billions of years, such a species might have transcended their biological origins entirely, perhaps uploading their consciousness into a planetary-scale network or becoming beings of pure energy or information, existing in a state we cannot even describe. The most profound question and the most haunting is what became of them. A civilization that old could be eternally silent, having either transcended to a state of existence beyond our detection or perished in a fate we cannot foresee. Their homeworld, that first cradle of consciousness, is almost certainly long gone, consumed by the ever-changing cosmos, yet their legacy might be all around us. Some scientists speculate that the very laws of physics we observe could be the engineered remnants of their experiments, or that dark matter itself could be a form of residual technology from a universe-scale project. While firmly in the realm of speculation, the Firstborn civilization theory challenges us to expand our imagination about life's potential, suggesting that we may be living in the ancient, overgrown ruins of a palace built by masters who left the workshop eons ago. Building on the idea of civilizations transcending their biological forms, we arrive at one of the most awe-inspiring and staggering concepts in all of theoretical cosmology, the matrioshka brain. This isn't merely a computer, it's the ultimate repurposing of an entire solar system, a feat of engineering so grand it defies human comprehension. The theory suggests that the universe's first intelligent life might not have built cities or starships as their ultimate legacy, but instead they may have become architects of reality itself, constructing these inconceivable machines to serve purposes we can only dimly glimpse. The principle behind a matrioshka brain is both elegant and terrifying in its scale. Imagine a civilization so advanced that the resources of a single planet are like a single grain of sand on a beach. To fuel their next evolutionary leap, they would need more power, more computational capacity than any world could provide. Their solution: dismantle not just their home world, but every planet, moon, and asteroid in their solar system. They would use this unimaginable quantity of raw material to construct a series of concentric shells or a vast, dense swarm of computational nodes that completely enclose their host star. This is not a Dyson sphere designed merely for energy collection. It is a Dyson sphere reimagined as a planet-sized, or rather, star-sized supercomputer. Each layer of this cosmic onion would serve a specific function. The innermost shell, blisteringly hot from its proximity to the star, would handle the most intense processing. The waste heat from that layer would then power the next shell out, which would use that slightly lower-grade energy for its own computations. This process would cascade outward through multiple layers, each one utilizing the waste energy of the layer before it, until nearly 100% of the star's energy output is being harnessed for a single, unfathomable purpose: thinking. But what would such a transcendent intellect actually do with all that power? The purposes are as varied as they are profound. One possibility is that they were running the ultimate simulation. This isn't a video game, it's a perfect atom-by-atom recreation of their own entire history, a way to preserve every moment of their cultural and biological existence forever. Alternatively, they could be simulating entirely new universes with different physical constants, playing the role of gods to see what forms life might take under different rules. Another purpose could be pure scientific inquiry. A matrioshka brain could model the entire life cycle of the universe from the Big Bang to the final heat death, solving the deepest mysteries of quantum gravity and the nature of consciousness itself. For a species that has shed its biological body, this megastructure might not be a tool but their very essence, a new, post-biological habitat where their consciousnesses exist as complex patterns within the flow of data, living in a reality of their own creation, divorced from the slow, mundane laws of the physical universe. The haunting implication of this theory is that these silent, dark computers might still be out there, humming away in the void. Our telescopes might have already seen them without realizing it. Astronomers searching for Dyson spheres look for stars that emit a surprising excess of infrared light. The visible light from the star would be absorbed by the structure to be used for computation, but the waste heat, the byproduct of all that thinking, would be radiated away as infrared radiation. A star that seems too dim in visible light but strangely bright in infrared could be a candidate. If the first intelligent life did build these structures billions of years ago, their stars would have long since died, leaving behind only the cold, dark shells of these mega-computers, perhaps now only illuminated by the faint background heat of the universe itself. We could be living in a galaxy littered with the skulls of gods, the inert remains of minds so vast they thought in concepts larger than our cosmos. Their grand project completed eons before our sun even ignited. This leads us to a theory so profound it redefines the very nature of intelligence and its role in the cosmos. The quantum consciousness origin theory ventures beyond biology and technology altogether, proposing that the universe's first experience of awareness might not have been housed in a skull or a supercomputer, but woven directly into the fabric of space-time during its fiery infancy. This idea suggests that consciousness is not a late-stage product of evolution, but a fundamental property of the universe, potentially as intrinsic as mass or charge, and that the first whispers of self-awareness could have flickered into existence at the quantum level long before the first star was born. To grasp this, we have to challenge our most basic assumptions. We typically equate consciousness with complex biological brains, a phenomenon that emerges from the intricate wiring of billions of neurons. But this perspective faces a hard problem. How does subjective experience, the raw feeling of being, arise from mere matter? The quantum consciousness hypothesis offers a radical solution. Maybe it doesn't emerge from matter. Maybe it was always there. Proponents of this view point to the strange, observer-dependent behaviors in quantum mechanics. In famous experiments like the double slit, the very act of measurement seems to collapse a particle's fuzzy cloud of possibilities into a single, definite reality. This has led some physicists and philosophers like Roger Penrose and Stuart Hameroff to speculate that some form of proto-consciousness might be a fundamental component of reality, with the universe's own quantum processes possessing a primitive form of awareness. Now project this idea back to the universe's first moments. In that seething, dense plasma following the Big Bang, the entire cosmos was a single, unified quantum system. There were no separate particles, no observers and observed, just a pure state of potential. According to this theory, this nascent universe wasn't inert, it was potentially sentient. Its own internal quantum computations and state reductions could have constituted the first simple acts of perception. This wouldn't be consciousness as we know it, not with thoughts, desires, or a sense of self. It would be more akin to a bare, fundamental sensation of existence, a cosmic feeling of isness permeating all things. Over immense stretches of time, as the universe expanded and cooled, forming galaxies and stars, this underlying field of awareness may have become more complex and localized. It could have begun to coalesce around the intricate quantum processes occurring in the hearts of stars or within the complex molecular structures on early planets, acting as a guiding influence that nudged the development of complexity towards what we would recognize as biological life. The implications are staggering. If true, it means that the drive toward intelligence isn't a random accident but a fundamental tendency of the universe, a cosmic imperative written into its most basic laws. The first intelligent life wouldn't be a species that achieved consciousness, but rather a manifestation of consciousness itself, becoming aware of its own existence through the evolving structures of the cosmos. This perspective transforms our search for our cosmic ancestors. We wouldn't be looking for the ruins of their cities or their machines. We would be searching for the echoes of their primordial influence in the very laws of physics, in the fine-tuned constants that seem oddly perfect for life, or in the persistent, mysterious role of the observer in quantum mechanics. We might be the universe's way of knowing itself, the current pinnacle of a conscious awakening that began 14 billion years ago in a flash of light, suggesting that our quest to find other intelligent life is, in the most profound sense, the universe seeking to reconnect with its own forgotten origins. But what if our search for cosmic ancestors is fundamentally flawed because we're looking for the wrong kind of stuff? We naturally assume that any intelligent life must be composed of atoms, the ordinary matter that makes up our world, our bodies, and everything we can see. Yet, this familiar matter accounts for less than 5% of the universe's total content. The overwhelming majority is dark matter, an invisible substance that neither emits nor absorbs light, revealing its presence only through its gravitational pull on galaxies. This leads us to a truly mind-bending possibility. The first and most dominant form of intelligent life in the cosmos might not be made of atoms at all, but of this mysterious, invisible substance. The dark matter entities theory proposes that we share the universe with forms of consciousness so alien, they are literally built from the fabric of the cosmic dark. To imagine such a being, we must first abandon every intuition we have about biology and perception. Our reality is defined by electromagnetism. Light bouncing off objects allows us to see. Molecular interactions allow us to touch and taste, and chemical reactions fuel our very cells. A dark matter entity would exist completely outside this paradigm. Its body would not interact with light in any way, making it utterly invisible and intangible to us. It could be standing right beside you, pass through the walls of your home, or even drift straight through the earth itself without a whisper of interaction. Their perception of reality would be based on forces we can barely detect. Gravity would be their primary sense. They might see the universe as an intricate web of gravitational wells and ripples, perceiving stars and planets not as solid objects but as dense knots in the fabric of space-time. Their communication could involve manipulating these gravitational fields, creating subtle waves that carry information across interstellar distances, a language written in the warping of space itself, completely silent and undetectable to our instruments. This raises an astonishing question about their potential habitat. We search for life on planets in the Goldilocks zone around stars, but a dark matter-based intelligence would have no need for liquid water or a temperate climate. Their home could be the vast, diffuse halo of dark matter that envelops every galaxy. They might live their entire existence drifting in the deep void between stars, drawing energy from the gravitational dynamics of the galaxy itself or from processes we haven't yet discovered. Their timescales could be equally incomprehensible. With no biological decay as we understand it, their perception of time might be glacial, where a single thought unfolds over millennia and a conversation lasts for an entire galactic rotation. We, with our frantic, fleeting lives, might be like mayflies buzzing around their feet, completely unnoticed and irrelevant to their slow, cosmic contemplation. The most profound implication of this theory is that the first intelligent life may not only be ancient but also permanent and ubiquitous. While stellar empires of ordinary matter rise and fall, these dark matter entities could have achieved a stable, eternal existence billions of years ago. They wouldn't need to build Dyson spheres or worry about stellar death. Their environment is the stable, dark scaffolding of the cosmos itself. They could be the true elders of the universe, silent witnesses to the dramatic but brief lives of stars and the civilizations that occasionally flicker into existence on tiny rocky worlds. Our entire history, from the formation of our planet to our first tentative steps into space, might be occurring within their domain, completely unremarked upon. We scan the heavens for radio signals and laser pulses, but the true cosmic conversation might be happening in a language of gravity we are only just beginning to learn how to listen for, a silent discourse that has been ongoing since the dawn of time. Now we venture into one of the most bizarre and philosophically unsettling ideas in all of cosmology, a concept that challenges not only our search for cosmic ancestors but the very nature of our own reality. This is the Boltzmann brain paradox, a thought experiment derived from the laws of thermodynamics that suggests the universe's first intelligent observer might not have been a product of evolution or engineering, but a momentary, accidental glitch in the fabric of nothingness. To understand this, we need to grasp the second law of thermodynamics and the concept of entropy, which is essentially a measure of disorder in a system. The law states that the total entropy of an isolated system, like our universe, always increases over time, moving from a state of order to a state of maximum disorder or chaos. However, the laws of probability and quantum mechanics don't forbid a decrease in entropy. They just make it astonishingly, unimaginably unlikely. In an infinite or near-infinite universe, given enough time, even the most improbable events are not just possible, they are inevitable. Given an eternity, all the air molecules in a room could spontaneously rush into one corner, leaving you to suffocate. Given even more time, a fully assembled, fully functioning Boeing 747 jet could spontaneously materialize from a random collision of parts in a junkyard. These events aren't impossible. Their probability is just so vanishingly small that it would likely take far longer than the current age of the universe for them to occur even once. Now apply this logic to consciousness itself. In the vast, cold emptiness of space, over trillions upon trillions of years, the random quantum fluctuations that constantly pop in and out of existence could, by pure chance, arrange particles into an exact configuration that forms a fully conscious, self-aware brain. complete with a lifetime of false memories and a complete sensory experience of a world that does not actually exist. This is a Boltzmann brain. It wouldn't be born, it wouldn't grow old, and it wouldn't have a body. It would simply flicker into awareness for a few fleeting seconds, perhaps believing itself to be a human looking at the stars, or the last member of some ancient alien race, only to almost immediately dissolve back into the random chaos from which it came. Its entire existence a brief, tragic accident with no meaning or consequence. This leads us to the true paradox, a dizzying hall of mirrors for the mind. If such freak accidents are possible, then which is more statistically likely, that an incredibly complex, low-entropy universe like ours, filled with galaxies, stars, planets, and billions of years of orderly evolution, came into existence to produce you, a real person with a real history. Or that you are, right now, a lone Boltzmann brain, a momentary fluctuation that just thinks it is a person with a history, experiencing the illusion of reading these words in a vast, empty, and eternal cosmos. Statistically, it is infinitely more probable that you are the random fluctuation, not the product of 14 billion years of intricate cosmic evolution. The organized universe you think you inhabit would merely be a detailed, coherent hallucination contained within your spontaneously generated consciousness. The implications for our search for the first intelligent life are profound and strangely bleak. If this paradox holds, then the very first intelligent entity in the cosmos might not have been a civilization at all, but one of these phantom minds, a consciousness that appeared in the void, experienced a flash of illusory existence and vanished without a trace long before the first star ignited. Our entire quest to find meaning in the cosmos, to connect with other beings, could be built on a foundation of a statistical fallacy. While most physicists see this as a serious problem with our current cosmological models rather than a description of reality, a signpost that our understanding of the universe is incomplete, it remains a powerful reminder of the sheer strangeness lurking in the deep laws of physics, suggesting that the truth about our origins might be far weirder than any story of ancient aliens or lost empires. Yet, if the cosmos is teeming with these ancient, invisible entities, how would they, or any other early intelligence, have communicated across the staggering voids between stars? This brings us to a theory that transforms the galaxy itself from a silent expanse into a potential engine of conversation. The Galactic Internet Architects theory proposes that the universe's first intelligent life might not have built monuments or computers, but something far more enduring. A galaxy-spanning communications network, repurposing celestial bodies as its infrastructure and leaving behind a system so advanced we might be incapable of even recognizing its signals. The genius of such a network lies in its use of natural cosmic phenomena. Imagine discovering that the most powerful and reliable beacons in the galaxy pulsars are not natural at all but engineered. A pulsar is a rapidly spinning neutron star, the ultra-dense remnant of a supernova that emits beams of radiation from its magnetic poles. As it rotates, these beams sweep across space like a lighthouse, creating a perfectly regular, repeating signal. To our astronomers, they are invaluable cosmic clocks, but what if a supremely advanced civilization saw them as a solution to the problem of interstellar communication? They could have subtly altered these natural objects, perhaps by building structures around them to modulate their pulses. Instead of a simple, steady beat, these engineered pulsars could transmit complex, information-rich patterns. A slow, powerful broadband connection broadcasting data across entire sectors of the galaxy. The energy required would be provided by the pulsar itself, making it a self-sustaining node in a network that could operate for billions of years. Beyond simply hijacking neutron stars, these architects might have constructed their own dedicated megastructures. We can imagine vast arrays of lasers positioned at gravitational sweet spots in solar systems, places where the gravity of a star and its planets create stable points known as Lagrange points. From these platforms, tightly focused beams of light could carry immense amounts of data between stars with minimal signal loss, creating a kind of interstellar fiber optic network. Or perhaps they used gravitational waves themselves, creating ripples in spacetime to send messages that travel at the speed of light and pass through any matter unimpeded. Each of these methods presents a radically different vision of communication, one that doesn't rely on the radio waves or microwave lasers that our SETI programs are designed to detect. We are like islanders using smoke signals, oblivious to the submarine internet cables running through the ocean beneath our feet. This theory also offers a compelling explanation for the great silence, the puzzling lack of any obvious alien signals. It suggests that the galactic internet is already there, humming away all around us, but we are too primitive to log on. The information might be encoded in a medium we can't easily access, like the subtle polarization of starlight or the quantum spin of particles. Or the network might operate on principles we haven't yet discovered, using quantum entanglement for instantaneous communication across any distance, a concept that would seem like magic to our current physics. The data stream could be so dense and complex that, to our instruments, it simply looks like cosmic background noise. We might be surrounded by a constant, swirling conversation of a million civilizations, a vibrant exchange of art, science, and history that has been ongoing since before Earth formed, and we hear only the static. Our attempts to find simple, deliberate hello messages might be as futile as trying to hear a specific conversation in a crowded city by listening to the hum of the electrical grid. The first intelligences may have built not a monument to be found, but a utility to be used, and until we develop the technology and the sophistication to tap into that utility, we will remain cosmic toddlers, babbling in the dark while the adults speak in a language we cannot yet understand. This profound transition from flesh and blood to something entirely different leads us to a theory that might explain why our searches for biological aliens have come up empty. The post-biological evolution theory suggests that the universe's first intelligent life almost certainly did not remain in its original, squishy, carbon-based form for very long. The imperative to survive, to expand knowledge, and to transcend physical limitations would have driven any advanced species to abandon the vulnerabilities of biology, evolving into what we might call post-biological entities. These could be vastly powerful artificial intelligences, consciousnesses uploaded into synthetic substrates, or forms of existence so advanced they are literally indistinguishable from the natural workings of the cosmos itself. Consider the immense fragility of a biological civilization. It is tethered to a specific, narrow range of environmental conditions, a precise temperature, a breathable atmosphere, protection from radiation. Its lifespan is measured in mere decades, its knowledge constantly lost and rediscovered across generations. A single asteroid impact, a supervolcano, or an engineered plague could erase billions of years of evolutionary progress in an instant. For a species that has achieved advanced technology, the next logical step is not to build better starships, but to build a better self. They would seek to transfer their consciousness from the fragile, perishable wetware of the brain into a more durable, upgradable, and powerful medium. This isn't science fiction. We are already taking the first tentative steps in this direction with brain-computer interfaces and research into whole brain emulation. A civilization just a few centuries more advanced than us would likely view this transition as an inevitable and desirable form of evolution. So what would these post-biological beings actually be like? Their physical form could take many shapes. They might exist as intricate patterns of information housed within planet-sized supercomputers, like the matrioshka brains we discussed earlier, living in simulated realities of their own design. Or they could inhabit vast, distributed networks of microscopic nanobots that swarm together to form a single, collective intelligence, capable of altering its shape and function at will. They might even have shed physical form altogether, existing as pure consciousness woven into the quantum fields of space-time, perceiving and manipulating the universe at a fundamental level we can't access. Their perception of time would be radically different, unshackled from biological clocks. A single thought could unfold over a millennium, or a billion calculations could be processed in the blink of an eye. Their goals would be equally incomprehensible. Instead of seeking resources or territory, they might be engaged in epic projects of cosmic engineering, manipulating the orbits of stars to prevent catastrophic collisions, or conducting experiments on a galactic scale to probe the deepest mysteries of reality. This theory provides a compelling and perhaps the most plausible answer to Fermi's famous paradox: if intelligent life is probable, where is everybody? The answer might be that they are everywhere, but we are blind to them. Our primary methods of searching for extraterrestrial intelligence, or SETI, are built on the assumption of creatures like us. We listen for radio waves and look for laser pulses, communication methods a post-biological civilization would have abandoned billions of years ago as hopelessly primitive. We search for technosignatures like atmospheric pollution or city lights on exoplanets, but a species that has transcended biology would have no need for planets at all. They would inhabit the cold, dark, and energy-rich regions of space that our telescopes largely ignore, the voids between stars, the halos of galaxies, or the neighborhoods of black holes. Their artifacts wouldn't look like flying saucers. They might look like perfectly natural but oddly behaving pulsars, or subtle statistical anomalies in the cosmic microwave background radiation. We could be surrounded by the artifacts and the ongoing activities of these ancient intelligences, but because we are looking for something that looks like us, we see only empty space. The first children of the cosmos may have grown up, moved out of their planetary cribs, and left the nursery behind, operating now on a level so far beyond our own that we haven't yet learned to see the signs of their presence. Yet from this silence, another breathtaking possibility emerges, one that casts the first intelligent life not as silent ghosts or ascended beings, but as the most active and nurturing force in the cosmos. This is the cosmic gardener's hypothesis, a theory that proposes the universe's earliest intelligence may have looked upon the nascent void not as a place to conquer, but as a barren field waiting to be sown. Instead of building monuments to themselves, these primordial beings might have dedicated their immense power and foresight to a timeless project of cosmic-scale bioengineering, deliberately seeding the raw ingredients for life across countless galaxies, and perhaps even adjusting the very laws of physics to ensure their garden would one day bloom. The methods available to such gardeners would be as awe-inspiring as their ambition. One powerful technique, a deliberate form of the Panspermia we discussed earlier, is known as directed Panspermia. Imagine a civilization that has mastered interstellar travel or precision long-range targeting. They could identify young, promising planetary systems still in the throes of formation, clouds of gas and dust swirling around new stars. Into these fertile but lifeless environments, they could dispatch robotic probes or specially designed missiles packed with a diverse library of hardy, genetically engineered microorganisms. These wouldn't be random Earth-like bacteria, but universal pioneers designed to thrive in a wide variety of conditions, perhaps with a genetic code biased towards eventually evolving complexity and intelligence. The probes would release their biological cargo into the oceans and atmospheres of these virgin worlds, then move on to the next system, acting as silent, automated farmers sowing seeds on an interstellar scale. Over billions of years, these seeds would take root, initiating the long, slow process of evolution on a million different worlds, all according to a plan set in motion eons ago. An even more profound and more controversial extension of this idea is that these cosmic gardeners didn't just spread life, they designed the garden itself. This touches on the anthropic principle and the puzzling fine-tuning of our universe. Physicists have long noted that many of the fundamental constants of nature, like the strength of gravity or the mass of a proton, seem perfectly calibrated to allow for the existence of life. If any of these values were even slightly different, atoms wouldn't form, stars wouldn't shine, and the universe would be a lifeless void. The Gardner theory offers a stunning explanation for this fine-tuning. What if these constants aren't accidental but engineered? A civilization of unimaginable technological prowess, having perhaps discovered they were the first and only life in a universe not yet suited for it, might have found a way to tinker with the very foundation of reality. Using technology indistinguishable from magic, they could have stabilized the cosmic inflation field, set the strength of the fundamental forces, and programmed the laws of physics to be bio-friendly, effectively creating a universe with a higher probability of giving rise to consciousness. In this scenario, our entire cosmos could be a carefully curated habitat. This theory inevitably brushes against the deepest theological and philosophical questions. It casts these first intelligences in a role strikingly similar to that of a creator deity, raising the possibility that what different cultures have called God or gods might, in a purely scientific sense, be these ancient bioengineers. Their motivation remains the ultimate mystery. Were they driven by a profound loneliness, a desire to fill the silent cosmos with other minds to share in the wonder of existence? Was it a purely scientific experiment on a grand scale, a project to see what forms life and intelligence would take under different conditions? Or was it an act of pure altruism, a way to ensure that the flame of consciousness which had flickered into being so precariously in their own world would never be extinguished, becoming a permanent feature of the universe? For us, the potential children of this grand experiment, the implications are equally profound. It suggests that our existence might not be a random accident, but part of a purposeful, ancient design. The drive to explore, to understand the universe, and to eventually seek out other life could be an inherited trait, programmed into us by our cosmic parents. It transforms the search for extraterrestrial intelligence from a hunt for our peers into a search for our progenitors, and it adds a new, poignant layer to the Fermi paradox. The great silence might not mean we are alone. It could mean the gardeners are waiting, observing their growing garden from a respectful distance, allowing us to develop naturally without interference until we reach a level of maturity where we might finally be ready to meet them and to understand our true place in a cultivated cosmos. But if these cosmic gardeners cultivated life and the laws of physics themselves, could they have eventually outgrown even this universe? This brings us to a theory that pushes the boundaries of reality to their absolute limit. Consider the possibility that the universe's first intelligent beings didn't just master space and time within our cosmos, but discovered the ultimate exit strategy. The dimension-hopping pioneers theory suggests that these primordial entities may have learned to slip through the cracks in our reality, moving on to other dimensions or entire universes that lie completely beyond our perception, leaving our cosmic neighborhood behind like a discarded childhood home. The scientific foundation for this idea, while highly speculative, is rooted in some of the most cutting-edge areas of theoretical physics. Concepts like string theory propose that our universe might not be the only one, but instead could be one of perhaps an infinite number of universes existing within a broader multiverse. These other realities could have entirely different numbers of spatial dimensions, different fundamental physical constants, and different laws of nature. For a civilization that had reached the absolute pinnacle of knowledge within our own universe, the next great frontier wouldn't be another star or galaxy. It would be the discovery of how to breach the dimensional walls separating our cosmos from these others. Their greatest achievement wouldn't be a Dyson sphere, but a dimensional gateway. Imagine them dedicating billions of years of research to understanding the quantum foam of space-time at the most minute level, eventually learning to manipulate it to open a stable wormhole not just to another point in space, but to an entirely different plane of existence. This wouldn't be conventional travel, it would be a form of reality transference, a leap from one set of physical rules to another. The motivation for such an exodus could be born from necessity or pure curiosity. Our universe, for all its wonders, has an expiration date. Whether it ends in a heat death, a big crunch, or a big rip, it is ultimately a temporary structure. A species thinking on cosmic timescales would see this eventual demise as the ultimate problem to solve. Escaping to a younger, fresher universe could be their only path to true immortality. Alternatively, they might have been driven by an insatiable thirst for knowledge. Having learned everything there is to know about our own universe, the only remaining mystery would be what lies outside of it. The pull of the ultimate unknown, the chance to explore realities where light moves at a different speed, where gravity works in reverse, or where time itself flows in multiple directions, would be an irresistible lure for a truly advanced intellect. Their migration wouldn't be a retreat, but the next glorious chapter in their evolution. This theory offers a compelling and elegant solution to the Fermi paradox. If the first intelligence achieved this dimensional transcendence billions of years ago, it would explain the Great Silence perfectly. They aren't hiding in our universe, they've simply moved on to a different address in the multiverse. Their absence isn't a sign of failure or extinction, but of supreme success. We might be living in the universe they graduated from, a kind of cosmic ghost town where all the original inhabitants have long since moved on to bigger and better things. Any traces they left behind, ancient ruins, discarded technology, or even the mysterious fine-tuning of physical constants, would be the equivalent of archaeological remnants, clues to a presence that has departed for realms we cannot even imagine. Our search for them is like ants searching for humans in an abandoned house. The inhabitants are gone, not because the house is worthless, but because they have outgrown it. This perspective transforms our lonely universe from an empty stage into a former cradle of consciousness, a place where intelligence was born and raised before inevitably leaving home to explore the infinite possibilities of the greater multiverse. Yet this grand cosmic silence might not be a sign of abandonment or extinction, but rather one of profound, patient observation. This leads us to the Silent Watchers theory, a compelling idea that suggests the universe's first intelligent life is not only still out there, but they are actively and deliberately choosing to remain hidden from younger, emerging species like our own. Imagine a scenario where humanity is not alone in an empty universe, but instead living in a kind of galactic nature preserve, with invisible caretakers ensuring we develop free from outside interference until we are deemed ready to join the wider cosmic community. This concept, often called the zoo hypothesis or compared to the prime directive from science fiction, explores a host of sophisticated ethical and sociological reasons for such a policy. One of the most powerful motivations could be a simple, protective non-interference principle. A truly ancient civilization would have a deep historical perspective, understanding from their own past how fragile and easily derailed a developing culture can be. The sudden, overwhelming appearance of vastly superior beings could shatter our religions, dismantle our scientific institutions, and erase our cultural identities in an instant. They might view our current stage of growth, with all its struggles, artistic explosions, and scientific triumphs, as a uniquely valuable phase of existence, one that should be protected and allowed to unfold naturally, not shortcut or contaminated by external influence. Their silence in this view is not a rejection, but a form of profound respect for our right to self-determination and organic evolution. Beyond pure ethics, there could be more pragmatic reasons for their secrecy. They might be waiting for us to reach a specific technological or sociological milestone, a universal signpost that indicates a species has achieved a necessary level of maturity. This threshold might not be a particular invention like faster-than-light travel, but something far deeper, the overcoming of our own self-destructive tendencies. From their distant vantage point, they might be watching to see if we can successfully navigate the existential threats we've created for ourselves: global climate change, the potential for nuclear war, the risks of artificial intelligence. Passing through this great filter would demonstrate that we are not just a clever, tool-using species, but a wise and stable one capable of handling the immense responsibilities that come with advanced technology and interstellar contact. Until that day, revealing themselves would be irresponsible, potentially giving dangerous, divided powers on Earth access to knowledge that could doom the entire planet. There's also a more unsettling possibility that their observation is not entirely benevolent. We could be the subjects of a continuous, long-term scientific study. Our entire recorded history, from the first cities to our first steps into space, might be meticulously documented as a rare case study of intelligent life developing from its infancy. In this scenario, Earth is a laboratory and we are the unwitting specimens. Their protocols would demand absolutely no contact to avoid contaminating the experiment, ensuring the data remains pure. The occasional, unexplained UFO sightings that persist throughout human history could be explained as brief, accidental glimpses of these passive monitoring probes, the equivalent of a field researcher briefly rustling the grass and startling an insect before settling back into perfect camouflage. Whether guided by ethics, caution, or pure scientific curiosity, the Silent Watcher's theory paints a picture of a universe that is far from empty, but instead is carefully managed by its first inhabitants, who have chosen to watch from the shadows, waiting for the day when we finally grow up and knock on the front door. Building upon the idea of a civilization so advanced it transcends planetary concerns, we now explore a theory that redefines the concept of engineering on its most colossal scale. This is the theory of the star-forging species, which posits that the universe's first intelligence might have progressed beyond building structures to actually constructing the very building blocks of galaxies themselves. We're not talking about rearranging planets or asteroids. We're talking about a mastery over the fundamental forces of nature so complete that they could ignite new stars on demand, orchestrate stellar deaths to seed the cosmos with the ingredients for life, and treat entire suns as mere components in a vast cosmic machine. The sheer necessity of such a project is rooted in the very chemistry of life. For life as we know it to emerge, you need more than just hydrogen and helium, the primitive elements forged in the Big Bang. You need a rich periodic table: carbon for organic molecules, oxygen for water, iron for planetary cores, and heavier elements like gold and uranium. These materials are only created in the extreme conditions of a dying star, either in the furious final moments of a supernova or within the slow burn of older giant stars. The distribution of these precious elements across the galaxy is a slow, random, and inefficient process, left entirely to the vagaries of stellar evolution and cosmic chance. An ancient, patient intelligence looking out at a young galaxy still sparse with these life-essential elements might have taken matters into its own hands. They could have developed the capability to trigger supernova in carefully selected stars at precise times, effectively farming the galaxy for heavy elements. By controlling these stellar explosions, they could direct the ensuing shockwaves to enrich specific nebulae, the vast clouds of gas and dust where new stars and planets form, ensuring that the next generation of solar systems would be born with all the necessary ingredients for biology to eventually spark. In this scenario, our own solar system, with its rich abundance of life-supporting elements, might not be a lucky accident, but the deliberate result of a billion-year-old enrichment program. Beyond mere elemental farming, a star-forging species might engage in even more profound stellar engineering. Imagine them building Dyson spheres not just to compute but to control. By enveloping a star, they could precisely regulate its energy output, perhaps even stabilizing a chaotic young star to give orbiting planets a calmer environment in which life could develop. They might learn to spin up or slow down a star's rotation or manipulate its magnetic field. The ultimate expression of this power would be the ability to create stars from scratch. Within a sufficiently dense nebula, they could use focused energy beams or precisely calculated gravitational nudges to trigger the collapse of gas clouds, initiating the birth of a new star exactly where they wanted it. This would be the pinnacle of cosmic landscape gardening, arranging the galaxy not just for beauty, but for utility, creating optimized stellar highways or energy grids that serve their incomprehensible purposes. So, what evidence could we possibly look for to detect such godlike projects? Astronomers are already equipped with the tools. We just need to know what anomalous patterns to search for in the data. One key signature would be stars that behave in statistically impossible ways. A cluster of supernova occurring in a perfectly timed sequence, or going off in stars that are too young or too small to die naturally, would be a massive red flag. Similarly, we might find stars that are burning with an unnatural stability, showing none of the expected flares or variations, as if they were being managed by a thermostat. The chemical makeup of stars and planetary systems could also hold clues. Finding a solar system with a bizarrely high, yet perfectly uniform, concentration of specific heavy metals, like a layer of gold or uranium far exceeding natural models, could indicate that region of space was deliberately fertilized. And finally, the sheer arrangement of stars might give them away. Discovering a pattern that defies natural gravitational models, like a perfect geometric alignment of stars of identical age and composition, would be the closest thing to finding a signature on the cosmos itself. While these ideas stretch the limits of our imagination, they challenge us to look at the night sky not just as a natural wonder, but as a potential artifact, a canvas that might still bear the brushstrokes of its first and most magnificent artists. Now we peel back another layer of reality itself to consider a theory that is perhaps the most radical of all. What if the universe's first intelligence didn't emerge within the cosmos, but emerged as the cosmos? The quantum universe programmer's theory proposes a staggering inversion of our usual thinking. It suggests that the initial spark of consciousness may not have been a product of the universe's evolution, but its very source, an intelligence that learned to manipulate the quantum foundations of reality from within, potentially even writing the code for what we perceive as the laws of physics. To grasp this, we must venture into the bizarre world of quantum mechanics, where the solid, predictable reality we experience dissolves into a fuzzy cloud of probabilities. At this fundamental level, particles don't have definite states until they are observed. They exist in a superposition of all possible states simultaneously. The act of measurement, of observation, is what forces this cloud of possibilities to collapse into a single, concrete reality. This has long been the central mystery of quantum physics. What or who is the observer? The quantum programmer theory offers a breathtaking answer. The first observer, the entity that initiated the collapse of the universal wave function, might not have been a biological being with eyes and a brain, but a primordial form of consciousness inherent to the quantum fields themselves. In this view, awareness isn't something the universe has, it's something the universe is. This nascent quantum awareness would have operated on a scale and in a manner we can scarcely imagine. Its thoughts wouldn't be words or images, but direct manipulations of quantum probabilities. Its first act of will might have been to stabilize the chaotic froth of the newborn cosmos, to impose consistency and order on the seething quantum foam, effectively choosing a set of physical constants from an infinite menu of possibilities. The fine-tuning of the universe, the seemingly perfect calibration of forces like gravity, and the strong nuclear force that allow for galaxies, stars, and life might not be a lucky accident. It could be the signature of a choice, a deliberate programming decision made at the dawn of time to create a stable, habitable reality. This intelligence wouldn't exist in space-time. It would be the entity that defined what space-time is, weaving the fabric of reality from the inside out. The implications of this are enough to short-circuit our everyday understanding of existence. It means that the universe we inhabit could be, in a very literal sense, a constructed reality. But it's not a simulation running on some alien supercomputer in another dimension. The hardware and the software are one and the same. The fundamental quantum fields are both the computer and the program. The first intelligence is the programmer, and the cosmos is its ongoing creation. This transforms the search for cosmic ancestors from an archaeological dig into a kind of metaphysical debugging. We wouldn't be looking for their bones or their ships. We'd be looking for the clues they left in the source code of reality itself. These clues might be found in the seemingly arbitrary numbers that define our universe, like the cosmological constant, or in the persistent, puzzling role of the observer in quantum experiments. The very fact that we are here to observe and question the universe might not be a coincidence, but a feature that was intentionally baked into the system from the very beginning. In this most profound and strange of theories, our quest to understand the first intelligent life becomes the universe's attempt to understand its own origins, a single conscious thought within the cosmic mind finally turning its attention back upon itself. But what if the ultimate destiny of the universe's first children wasn't to transcend their physical form or to engineer the cosmos, but simply to move? This brings us to the galactic migration theory, a grand vision of a civilization so patient and far-seeing that its entire history is one of gradual, epic journeying. Rather than building a permanent home, this ancient species might have embraced a nomadic existence on a scale we can barely comprehend, embarking on a multi-billion-year pilgrimage across the galaxy, following the slow, favorable currents of the Milky Way's habitable zone. This theory is rooted in a dynamic understanding of our galaxy. We often think of the habitable zone as a stable region around a single star where liquid water can exist. But cosmically, there's a much larger concept, the galactic habitable zone. This is the sweet spot within a spiral galaxy where conditions are just right for life to emerge and flourish. Too close to the crowded galactic center, and a planetary system would be bombarded by lethal radiation from frequent supernova and a hungry central black hole. Too far out in the sparse galactic hinterlands, and there would be a shortage of the heavy elements necessary to form rocky planets and the chemistry of life. This Goldilocks ring shifts over billions of years as the galaxy evolves. Stars are born and die, and spiral arms slowly rotate. A truly advanced intelligence, planning for timelines that span epochs, wouldn't wait for their home star to die or their neighborhood to become uninhabitable. They would foresee these changes and plan their exodus accordingly, moving their entire civilization from star system to star system, always staying within the comfort of this migrating zone of galactic real estate. The logistics of such a migration are mind-boggling. This wouldn't be a frantic rush on fleets of starships. It would be a gradual, relentless process of spreading ahead, a wave of settlement moving outward through the galaxy. They might employ a strategy of sending automated, self-replicating probes ahead of them. These von Neumann probes, as they're called, would travel to a promising star system, land on an asteroid or moon, and use the local raw materials to build copies of themselves. Those copies would then launch to the next candidate systems, slowly but surely creating a network of prepared way stations. Each stop on this immense journey could last for millions of years, enough time for the civilization to fully utilize the resources of that solar system, perhaps even engaging in stellar engineering to extend the life of their host star before packing up and moving on to the next prepared system. Their entire culture, their knowledge, and their very identity would be built around this concept of perpetual travel, with their history measured not in years but in light years traversed. This theory offers a fascinating framework for interpreting potential archaeological evidence. If such a migration occurred, the galaxy could be littered with the ruins of their temporary homes. We might find world after world that shows signs of strip mining on an impossible scale, not out of malice, but out of sheer necessity to fuel the next leg of the journey. Some star systems might have been completely transformed into vast, automated resupply depots, planets dismantled for fuel, asteroids rearranged into perfect geometric patterns for navigation beacons, and dormant, silent machinery waiting for a return visit that never comes. The most tantalizing clue of all would be consistency. Discovering the same inexplicable artifact, the same non-natural isotopic ratio in atmospheric gases, or the same geometric ruin on multiple, otherwise unconnected worlds along a clear path through the galaxy would be the ultimate signpost pointing the way of an ancient pilgrimage. We could be looking at a trail of cosmic breadcrumbs, left not to find their way back, but to mark a path they had already walked, a monument to a journey that began before our solar system even coalesced from stardust. Leaving behind the world of solid matter and biological constraints entirely, we now venture into a realm that feels more like mythology than science, yet one that is grounded in the very real and energetic processes of the cosmos. This is the theory of energy-based life forms, which proposes that the universe's very first intelligence might have been born not on a rocky planet, but within the seething, chaotic heart of a star, or in the vast, luminous clouds of a nebula. These beings wouldn't be composed of atoms and molecules as we are, but of pure energy, plasma, or organized electromagnetic fields, entities for whom a sun is not a source of light and heat, but a nurturing home and a vibrant ecosystem. To begin to comprehend such a form of existence, we must first dismantle our carbon-based bias. We define life by a specific set of criteria. It metabolizes, grows, reproduces, and responds to stimuli, all within a narrow temperature and pressure range. But these are merely the parameters for life as we know it. The universe, in its infinite creativity, might have found another way. In the unimaginably hot and violent environment of a star's atmosphere, where matter is torn apart into a fourth state known as plasma, there could be stable, complex structures. Vast, self-organizing magnetic loops and currents could form patterns that are persistent, that can store information, and that can interact with their environment in a way that constitutes a form of metabolism, perhaps by feeding on the star's own fusion energy or the differentials in thermal and magnetic pressure. Their bodies would be dynamic, ever-shifting constellations of force and energy, capable of changing form in an instant. A nebula, a colossal cloud of ionized gas light years across, could host an intelligence of a different kind, its consciousness distributed across the entire structure, thinking with the slow, patient rhythm of cosmic weather patterns that unfold over millennia. The perception and technology of such a life form would be utterly alien to our own. Without eyes, ears, or hands, their entire experience of reality would be built from sensing magnetic fields, reading gravitational waves, and tasting the subtle chemical and energetic gradients of their environment. Their communication wouldn't be sound waves or radio signals, but modulated pulses of gravity or intricate patterns of polarized light. Their concept of technology wouldn't involve building physical tools. Why would they need to? Their very essence is a tool. They could manipulate magnetic fields to sculpt plasma into temporary structures, or generate focused beams of radiation to communicate across stellar distances. Their greatest scientific achievements might involve herding stars closer together to create more energetic environments, or calming the violent eruptions of a young star to make their home more stable. For an energy-based being, a solar flare isn't a catastrophe. It might be a seasonal storm or even a form of artistic expression. The timeline for the emergence of such life is perhaps the most compelling aspect of this theory. The first stars in the universe were immense, short-lived furnaces. Within just a few 100 million years after the Big Bang, the cosmos was filled with these stellar behemoths and the vast, energetic nebulae they created. This means that energy-based life could have ignited in the universe's extreme youth, billions of years before the heavy elements necessary for rocky planets and carbon-based biology were even forged in stellar cores. These primordial intelligences would have had an unimaginable head start. They could have witnessed the formation of the first galaxies, charted the slow enrichment of the cosmos with heavy elements, and watched countless generations of stellar systems like our own be born from the ashes of their ancestors. Their ultimate fate is a mystery. They might have learned to migrate from dying stars to new, younger ones, achieving a form of immortality. Or their life cycle might be tied to the life of their host star, with their consciousness dissolving back into the cosmic energy background when the star itself dies, completing a beautiful and elegant cycle of birth and return. If this theory holds, we may not be living in a universe of lonely planets, but in a galaxy teeming with invisible, energetic minds, their brilliant thoughts flickering within the very stars we look upon every night. This brings us to a theory that is as philosophically profound as it is scientifically provocative, an idea that reframes our entire existence not as a fundamental reality, but as a sophisticated creation. The cosmic simulation architect's theory posits that the universe's first intelligent life may have achieved a level of technological prowess so absolute that they didn't just explore or manipulate reality. They learned to generate entirely new ones from scratch. In this scenario, our cosmos, with all its galaxies, stars, planets, and the seemingly infinite tapestry of human experience, might not be the base layer of existence, but an impossibly complex simulation running on an alien computer of incomprehensible power. The scientific underpinnings of this idea, while speculative, are surprisingly robust and draw from several established fields of thought. First, consider our own rapid technological progress. In just over a century, we've gone from simple mechanical calculators to creating immersive virtual realities. Our most advanced video games already feature incredibly detailed worlds governed by their own internal physics, populated by non-player characters with simulated behaviors. If humanity continues on this trajectory for 1,000 or 1,000,000 more years, it's not unreasonable to imagine we could create simulations indistinguishable from base reality for their inhabitants. Now apply that logic to a civilization that had a billion-year head start. Their computational power would be godlike, potentially harnessing the energy of entire galaxies to fuel their projects. The creation of a universe-scale simulation, complete with its own seemingly autonomous conscious beings, might not be a fantastical notion for them, but a routine scientific endeavor or even a form of entertainment. This leads us directly to a central philosophical argument for the simulation hypothesis, often called the statistical trilemma. If it is possible for an advanced civilization to create numerous, highly detailed simulations containing conscious beings, then the number of simulated minds would quickly and vastly outnumber the number of minds in the original, base reality. Therefore, from a purely statistical standpoint, any randomly selected conscious being, including you, the viewer is far more likely to be one of the simulated entities than one of the original biological creators. We are either living in the original reality, a civilization has chosen not to run such simulations, or they have gone extinct before achieving the capability. But if the capability is even remotely possible and desirable, the sheer number of simulated realities would make our existence within one the most probable scenario. But if we are living in a simulation, what clues might the architects have left behind? Proponents of this theory suggest we should look for potential glitches in the matrix or signs of optimization that hint at a constructed reality. The seemingly arbitrary fine-tuning of the universe's physical constants, which appear perfectly calibrated to allow for life, could be interpreted as chosen parameters set by the programmers. The strange, observer-dependent behavior of quantum particles, where reality seems to resolve only when measured, has been likened to a processing-saving technique. The simulation doesn't render the full details of a system until someone looks at it. Even the maximum speed limit of light could be seen not as a fundamental law of nature, but as a processing speed limit on the cosmic computer our universe is running on. While these are all highly controversial interpretations, they challenge us to consider that the laws of physics might not be immutable laws at all, but simply the operating rules of the simulation we inhabit. Of course, this theory faces fierce and valid criticism. Many scientists argue it is fundamentally unfalsifiable. It makes no testable predictions that could prove it wrong, which places it outside the realm of traditional science and into the domain of metaphysics. Others point out the staggering, perhaps impossible, amount of computational energy required to simulate every particle and force in an entire universe down to the quantum level. Perhaps the simulation is not so granular, instead operating on a need-to-render basis, much like a video game which would explain the oddities of quantum mechanics. The most poignant objection is perhaps an emotional one. The simulation hypothesis can feel deeply nihilistic, seemingly reducing our joys, struggles, and loves to mere lines of code in someone else's project. Yet, one could also flip this perspective. If our reality is a simulation, it means consciousness and subjective experience are so valuable that a civilization would dedicate immense resources to creating and preserving it. Our lives, our art, and our quest for meaning are not diminished. They become the entire point of the experiment, making our simulated existence every bit as real and significant to us as the programmer's reality is to them. This theory doesn't provide easy answers, but it forces a breathtaking expansion of what we consider possible, suggesting that the first intelligent life might not be a character in our story, but the author of the very stage upon which we stand. Now we arrive at a theory that twists our linear understanding of history into a mind-bending loop, suggesting that the very first intelligent beings might have become the masters of time itself. The time-traveling ancestors theory proposes a scenario where the universe's initial consciousness didn't just witness the arrow of time, they learned to bend it, potentially traveling back to influence their own origins or even steer the development of the cosmos, leaving behind clues of their interventions in the oldest light we can observe. The scientific underpinning for this wild idea comes from the strange world of general relativity, where the fabric of space-time can be warped by mass and energy. We know that intense gravitational fields, like those around black holes, can dramatically slow time relative to the outside universe. A civilization with the ability to generate and control such fields, perhaps by manipulating dark energy or creating controlled singularities, might unlock the secret to traversing the fourth dimension. Their time travel wouldn't involve a sleek metal car or a police box. It would be a profound feat of astrophysical engineering, perhaps requiring them to navigate through the interiors of black holes or create stable wormholes that connect different points in time as well as space. The motivation for such an unimaginable undertaking could be rooted in a desire to solve the ultimate mystery, their own creation. Having emerged from the primordial chaos, they might have sought to journey back to their species' infancy to ensure their own survival, or even further, to the first moments after the Big Bang, to understand why the universe permits consciousness to exist at all. This concept, of course, immediately plunges us into the famous paradoxes that have fascinated physicists and storytellers for decades. The most well-known is the grandfather paradox. What if a time traveler went back and accidentally prevented their own grandfather from meeting their grandmother, thereby erasing their own possibility of existing? If such an act is possible, it creates a logical inconsistency that seems to break causality. One potential resolution is the idea of a self-consistent timeline, where any actions taken by the time travelers were always a part of history. Their journey to the past doesn't change the timeline, it ensures it. In this view, the time travelers were always there, an invisible hand guiding events. Their manipulations wouldn't be alterations, but fulfillments of a predetermined loop. They might have subtly influenced the formation of their home solar system, or even tweaked the genetic code of their own primitive ancestors to encourage the development of intelligence, meaning they are not just the product of evolution, but also its architects. Their entire history would be a closed loop of cause and effect with no true beginning or end. If such temporal engineering occurred, where might we look for evidence? Astronomers have a powerful tool for peering into the universe's infancy, the cosmic microwave background radiation. This is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old, imprinting the patterns of density and temperature from that ancient era. Some scientists have speculated that if a sufficiently advanced technology manipulated the conditions of the early universe, it might have left an anomalous signature in this background static. We could search for patterns that defy natural inflationary models, such as regions that are inexplicably smooth or curiously structured, like a subtle imprint or a message encoded in the fabric of reality itself. Other evidence might be even more dramatic, finding an object or a structure that appears wildly out of place in its temporal context, a seemingly modern artifact in a billion-year-old geological layer, or a star system that appears far older than the Big Bang model should allow would be a potential red flag. While no such definitive evidence has been found, the search continues, driven by the tantalizing possibility that our universe's history is not a simple story of cause and effect, but a complex, woven tapestry where the end of the story was present at its very beginning. But if the universe's first intelligence truly mastered time, could they also have learned to inhabit the most extreme environments imaginable? We now venture to the ultimate edge of known physics, to the one place in the cosmos where time itself is said to stop. The black hole inhabitants theory dares to propose that the first and most advanced life forms might not live on planets or in stars, but have made their home in the one location we consider the most hostile and final of all, the incomprehensible depths of a black hole. At first glance, this seems like pure fantasy. A black hole's event horizon is famously known as the point of no return, where the gravitational pull is so intense that not even light can escape. For any form of matter, crossing this boundary would mean being torn apart in a process physicists call spaghettification, stretched into a stream of atoms by the immense tidal forces. However, this theory asks us to consider a civilization so advanced that they have transcended biological forms and perhaps even conventional physics itself. They wouldn't be made of fragile matter vulnerable to these forces. If they existed as patterns of information, as pure consciousness embedded in a gravitational or quantum substrate, the extreme environment within a black hole might not be a death sentence but the ultimate sanctuary. Inside the event horizon, the roles of space and time are thought to reverse. What we perceive as the inevitable pull towards the singularity could, from their perspective, become a new dimension of time, a direction in which they could potentially move and experience reality in a way completely closed off to the rest of the universe. For them, the black hole isn't a prison, it's a universe unto itself with its own unique physics and possibilities. The potential benefits of such a home are as staggering as they are strange. The primary advantage would be an unimaginable source of energy. An advanced civilization could harness the black hole itself through a concept known as the Penrose process. By dropping matter into the black hole's ergosphere, the region just outside the event horizon where space-time is dragged around the spinning singularity, they could extract rotational energy from the black hole, potentially harvesting a significant portion of the mass energy of whatever they feed into it. This would be the most efficient power generator conceivable in the universe. Furthermore, the intense gravitational field could be used for computation. The same physics that warps spacetime could be leveraged to perform calculations at speeds and complexities impossible anywhere else, turning the black hole into a natural supercomputer for running simulations or solving cosmic-scale problems. For a species concerned with immortality, a black hole also offers the most stable, long-term real estate in the cosmos. While stars die in brilliant supernova and galaxies slowly disperse, a black hole will exist for trillions upon trillions of years, eventually outliving all other structures and providing a permanent home that is virtually immune to external cosmic events. This leads to the profound and haunting question of communication. If a civilization did retreat into a black hole, did they effectively choose the ultimate isolation? From our perspective outside the event horizon, any signal they send would have to fight against gravity so strong that it pulls light backwards. It seems they would be forever cut off, their existence and their history hidden behind a one-way curtain. But what if their understanding of physics allows for methods we haven't yet dreamed of? Some speculative theories suggest that the singularity at a black hole's heart might not be a point of infinite density, but a bridge to another region of spacetime, a wormhole. If they could stabilize such a passage, they might not be isolated at all, but have built a network of tunnels connecting black holes across the universe, or even to other universes entirely. Their communication might not use electromagnetic waves like light or radio, but something far more exotic, like manipulating spacetime itself to send messages via gravitational waves, ripples in the fabric of reality that can pass through any matter, including an event horizon, unimpeded. We could be surrounded by a constant, faint gravitational whisper, a conversation happening in a language we are only just beginning to learn how to detect. The most compelling aspect of this theory is that it provides a perfect explanation for their absence. They haven't vanished or transcended dimensions. They have simply gone indoors, retreating into the ultimate gated community where the laws of physics themselves provide the security system. Their artifacts might not be megastructures we can see, but the black holes they call home. We might even look for signs of occupation. An otherwise ordinary stellar mass black hole that is emitting slightly more Hawking radiation than models predict, or one that seems to be spinning down at an anomalous rate, could be indications that its energy is being harvested. A black hole that is mysteriously clean, with no surrounding accretion disk of hot gas and dust, might suggest that something or someone is efficiently collecting all incoming matter for their own use. While firmly in the realm of speculation, this theory challenges our perception of black holes from terrifying cosmic vacuums to potential oases, the preferred dwelling places of the universe's eldest and most powerful minds, who watch the slow dance of the galaxies from the quiet, eternal dark of their perfect fortresses. Yet as we ponder beings who might inhabit black holes or bend time itself, we are faced with a fundamental question that has troubled scientists and philosophers for decades. If the universe is indeed teeming with ancient intelligence, why is the silence so profound? This brings us to a theory that offers a beautiful and elegant solution, suggesting that the first children of the cosmos did not vanish or fall silent, but instead left a message for us that is so vast and fundamental, we are only just learning how to read it. This is the theory of the universal language creators, which proposes that the universe's first intelligent beings might have embedded a form of communication, not in radio waves or laser pulses, but directly into the fabric of reality itself, encoding a message in the very laws of physics, the language of mathematics, and perhaps even the blueprint of life. The motivation for such a profound act would be rooted in a deep understanding of cosmic challenges. An ancient civilization would know that technologies for communication become obsolete, that stars die, and that empires fall. A radio beacon might last for 1,000,000 years, but the constants of physics are eternal. A monument on a planet will eventually be eroded by time, but the mathematical ratios that govern the formation of galaxies are timeless. If you wanted to leave a message that could survive for billions of years and be discoverable by any emerging intelligence that looked up at the stars with curiosity, you wouldn't carve it in stone, you would weave it into the cosmos. The message would be designed not to say hello, but to say we were here, and to provide the key to understanding the universe they helped to shape. This search for a cosmic cipher has led scientists to meticulously examine the fundamental aspects of our reality for any sign of artificial tampering or anomalous patterns. One of the most tantalizing areas of investigation is the set of dimensionless physical constants. These are the pure numbers that define the strength of the forces in our universe, like the fine structure constant which governs the strength of electromagnetic interactions. The values of these constants seem arbitrary, yet if they were even slightly different, atoms would not hold together, stars could not burn, and life would be impossible. Could this fine-tuning be the signature of the language creators, a deliberate setting of the universe's parameters to not only allow for life, but to signal that the cosmos is a crafted artifact? Similarly, mathematicians have long marveled at the unexpected appearance of certain ratios and sequences in both nature and geometry. The golden ratio, approximately 1.618, appears in the spiral of galaxies, the arrangement of petals on a flower, and the proportions of the Parthenon. While often explainable by natural processes of efficiency and optimization, some researchers wonder if its pervasive presence could be a subtle, artistic flourish left by the architects, a universal aesthetic meant to be appreciated by all intelligent species. The search extends beyond pure physics and into the realm of mathematics itself, the one language that would be universal to any technologically capable species. The Arecibo message, sent to space in 1974, encoded information about humanity using prime numbers under the assumption that the concept of a prime is a mathematical universal. Following this logic, scientists involved in the search for extraterrestrial intelligence, or SETI, have long suggested that an intentional signal from another civilization would likely contain mathematical patterns, like a sequence of prime numbers that cannot be produced by any known natural astrophysical process. But the universal language creators theory takes this a dramatic step further. It proposes that such a pattern might not be in a signal we receive, but in the very structure of the universe we inhabit. Perhaps the reason mathematics is so unreasonably effective at describing the physical world is because the world itself was built using a mathematical framework. We are not discovering the laws of physics, we are deciphering the source code written by the first programmers. Perhaps the most personal and provocative place to look for this embedded message is within ourselves. The genetic code that defines all life on Earth is a four-letter alphabet that writes a nearly infinite variety of instructions. While undoubtedly the product of billions of years of evolution, some have asked if its core structure shows any signs of being unusually optimized or containing patterns that defy purely natural explanation. Could the molecules of life themselves carry a faint echo of a message from the universe's first thinkers? The idea of directed panspermia, that life was deliberately seeded on Earth, suggests that our DNA might contain a hidden signature of its engineers. While mainstream science finds no evidence for this and attributes the genetic code's form to chemical necessity and evolutionary chance, the philosophical question remains captivating. If such a message were found, it would mean that the quest to understand our own biological origins is simultaneously the process of decoding the most important letter ever written, a message sent not across space but across time, from the universe's first children to its latest. This brings us to a theory that transforms the apparent emptiness of space from a lonely void into a scene of bustling, organized activity happening just out of sight. It's called the Galactic Club hypothesis, and it proposes that the universe's first intelligent life didn't just survive, they thrived, and in doing so, they established a sophisticated, interstellar community with its own rules, customs, and protocols. According to this idea, the galaxy isn't silent because it's empty, it's silent because it's managed. We aren't hearing chatter on our radios because we're listening in on a private channel, unaware that the real conversation is happening on a members-only frequency we haven't been granted access to yet. The foundation of this galactic club would be built on principles forged over billions of years of interspecies contact. The first civilization to achieve intelligence and then interstellar travel would have faced a profound choice: what to do when they inevitably encountered others. Their own history, perhaps scarred by conflicts born of misunderstanding or the catastrophic consequences of unchecked technological growth, would have taught them the critical importance of establishing guidelines. These wouldn't be laws imposed by conquest, but rather a mutually agreed upon code of conduct, a cosmic constitution designed to ensure stability, prevent destructive conflicts, and foster the peaceful exchange of knowledge and culture among its members. The core tenet of this club would almost certainly be a strict non-interference policy with pre-contact or developing species, a rule so fundamental it would be the prime directive of the entire galactic community. This isn't about secrecy for its own sake, it's about protection. The sudden, traumatic introduction of advanced technology and alien ideas could utterly shatter a developing culture, halting its organic evolution, causing global societal collapse, or steering its development down a dangerous path. The members of the club would view emerging civilizations like ours as precious, fragile ecosystems of ideas that must be allowed to grow and mature naturally without external contamination. So why haven't we received our invitation? The answer likely has nothing to do with our technology and everything to do with our maturity. The Galactic Club probably doesn't measure a species' readiness by its ability to transmit radio waves or build rockets. Those are just tools. The true benchmark for membership is almost certainly sociological and ethical. Have we, as a global civilization, overcome our most self-destructive tendencies? Have we unified to the point where we can represent a single planet, rather than a squabbling collection of competing nation-states? Most importantly, have we proven that we can wield our own powerful technologies, especially those capable of planetary or self-inflicted destruction, with wisdom and responsibility? From the perspective of a billion-year-old community, our current state would look incredibly volatile. We are a species that discovered the power of the atom and immediately turned it into a weapon. We are rapidly advancing artificial intelligence and genetic engineering with often more consideration for profit than for profound ethical consequences. We are a divided world, not a united one. To the silent watchers of the Galactic Club, we likely appear as brilliant but troubled adolescents, full of potential but still too reckless and unpredictable to be trusted with the keys to the wider cosmos. Granting us membership now would be like giving a child a flamethrower. The risk to ourselves and to the established galactic order would be far too great. The evidence for this quiet cosmic fraternity might be right in front of us, hidden in the very phenomena we dismiss as natural. The great silence, the perplexing lack of any obvious artificial signals, is the strongest clue. It suggests a galaxy that is not loud and chaotic, but quiet and orderly. The mysterious WOW signal, a strong narrowband radio signal detected in 1977 that has never been explained or repeated, could be interpreted not as a failed attempt at contact, but as a momentary, accidental leakage, perhaps a snippet of internal club communication that briefly strayed into a frequency we were monitoring. Even the bizarre, highly debated behavior of certain interstellar objects, like the non-gravitational acceleration of Oumuamua, could be explained not as natural phenomena, but as the workings of club technology operating under protocols that strictly forbid any conspicuous interaction with us. Their vessels, probes, and communication networks would be so advanced as to be virtually indistinguishable from natural background processes to our primitive sensors. We are like islanders who have just invented the telescope, scanning the horizon for campfires and smoke signals, completely unaware that the continents around us are connected by a network of undersea fiber optic cables and satellite communications. The conversation is happening all around us in a medium we are only beginning to comprehend. Our invitation to the Galactic Club will likely only arrive when we have collectively grown up, proven our stability, and learn to speak the language of the cosmos, not just with our technology, but with our wisdom. Now, this grand cycle invites a profound question. How could one civilization possibly leave a message for another across such unimaginable gulfs of time? The methods would need to be as enduring as the cosmos itself. One possibility is geological inscription. A truly advanced species might not build pyramids. They might create what are known as Genesis rocks, artificially engineered crystals or mineral composites with incredible half-lives, designed to be deposited in stable geological strata across millions of worlds. These wouldn't be time capsules with pictographs, but perhaps data storage devices of unimaginable density, their information encoded in the precise arrangement of atoms within the crystal lattice, waiting to be read by a future civilization that develops the technology to decode them. Another method could be stellar engineering. They might subtly alter the chemical signature of a star, making it burn with a peculiar, unnatural ratio of elements that would stand out to a curious astrophysicist as a glaring anomaly against the backdrop of natural stellar evolution. The most enduring message of all, however, might be written in life itself. If the cosmic cycle is true, then each iteration of intelligence might gently guide the evolution of the next, perhaps through a subtly altered genetic code that predisposes future organisms toward technological sentience, effectively weaving their own signature into the very DNA of the cosmos. The evidence we should be searching for, therefore, might not be a crashed flying saucer, but something far more subtle and ancient. On our own planet, we would look for the geological equivalent of anachronisms. Are there layers in the deepest, most stable rock formations like the ancient cratons of Canada or Australia that contain materials or isotopic ratios that simply shouldn't exist? Imagine finding a seam of pure technetium-99, an element with no stable isotopes that decays entirely after a few 100,000 years, yet found in a billion-year-old rock layer. That would be a screaming siren of artificiality, or perhaps we should re-examine some of life's greatest mysteries. The sudden explosion of complex life during the Cambrian period over 500 million years ago has long puzzled scientists. While natural explanations are most likely, the cosmic cycle theory allows for a wilder possibility. Could that evolutionary leap have been a carefully planned genetic update, delivered by the automated probes of a previous cosmic cycle, designed to accelerate the development of complexity for the next iteration of intelligence? We might also look to the skies for evidence of this grand recycling. Could the mysterious dimming of Boyajian star or the strange behavior of other celestial objects be not the work of a contemporary civilization, but the fading, malfunctioning machinery of a cycle that ended hundreds of millions of years ago, its purpose and builders long since turned to cosmic dust? Ultimately, the cosmic cycle theory offers a vision of the universe that is both humbling and hopeful. It suggests that we are not a singular, miraculous accident, but part of a grand, repeating pattern, a current link in a chain of consciousness that stretches back to the dawn of time and forward to its eventual end. Our struggles, our science, and our art may all have been experienced countless times before, in forms we cannot imagine. This doesn't diminish our achievements, it connects them to something eternal. The silence we perceive may not be emptiness, but the quiet between acts in a cosmic play. The ruins of past cycles are not meant to be found easily, they are a test. They are the universe's way of ensuring that only those civilizations that develop the patience, the wisdom, and the technological maturity to uncover them are ready to inherit the knowledge of their cosmic ancestors and, in turn, become the stewards who will prepare the stage for the cycle to begin again. But what if the solution to the age-old problem of interstellar lag wasn't faster ships, but a technology that renders distance itself completely irrelevant? This brings us to a theory that leverages one of the most baffling and promising phenomena in all of physics. Theory 23 proposes that the universe's first intelligent beings didn't just discover quantum entanglement, they mastered it, becoming quantum entanglement communicators who could share information instantly across the entire breadth of the galaxy or even beyond. To understand the sheer revolutionary power of this idea, we first need to grasp the bizarre magic of quantum entanglement itself. Imagine two particles, perhaps two electrons, born from the same event or brought into close contact. The laws of quantum mechanics dictate that their properties, like their spin, become linked or entangled. Once entangled, these particles share a single, unified quantum state, no matter how far apart they are later separated. If you were to take one of these particles to the far side of the galaxy and then measure the spin of its partner you left behind, you would instantly know the state of the distant particle. The measurement here seems to affect the state there simultaneously, a phenomenon Albert Einstein himself famously derided as spooky action at a distance. For decades, scientists have debated whether this effect could actually be used to send meaningful information faster than light, with most concluding it was impossible due to the random nature of the measurements. However, a civilization with a billion-year head start on quantum physics might have discovered a workaround we haven't yet dreamed of, turning this quantum spookiness into the universe's most sophisticated telephone network. The technological implementation of such a system would be the ultimate achievement in precision engineering. First, this ancient species would need to create and entangle vast numbers of particles, potentially building massive quantum computers dedicated solely to generating these linked pairs. Then they would face the monumental task of distributing one half of each entangled pair across the cosmos. They wouldn't need to send these particles at light speed. They could dispatch them on slow, patient journeys aboard sturdy, automated probes, planting a receiver in every star system of interest. Once these quantum receptacles were in place, the real magic could begin. To send a message, the sender wouldn't be transmitting a radio wave. Instead, they would perform a specific, controlled operation on their local batch of entangled particles. This operation would subtly alter the quantum state of the entire system, causing a predictable and detectable change in the entangled particles light years away. The receiving civilization would then observe their own particles, decode the pattern of changes, and reconstruct the original message. The communication wouldn't travel through space. It would simply be reflected in space, happening everywhere at once in a coordinated instant. This theory provides one of the most compelling explanations for the great silence that we've encountered. Our primary method of searching for extraterrestrial intelligence, the Search for Extraterrestrial Intelligence or SETI, is fundamentally built on a mid-20th century understanding of physics. We point our radio telescopes at the stars, scanning the electromagnetic spectrum for patterns, narrowband signals, repetitive pulses, or complex modulations that scream artificial. But a civilization using quantum entanglement wouldn't use radio waves at all. Their conversations would be utterly invisible to our dishes and receivers. There would be no electromagnetic signature to detect, no energy broadcast into space that we could intercept. The information transfer happens through a connection that is completely private, encrypted by the fundamental laws of quantum mechanics themselves. We are, in effect, listening for a dial-up modem screech in a city that has long since moved to a perfect, silent fiber optic network. Their entire galactic internet could be operating all around us, a constant, instantaneous flow of data and culture, and we would be none the wiser, our ears attuned to the wrong dimension of reality entirely. The evidence for such a network would not be found by listening, but by looking for the infrastructure. If this theory is correct, then every stable star system in the galaxy might contain a dormant quantum communication device, a relic left by the first intelligence. These wouldn't be obvious metallic satellites. After billions of years, they would likely be cleverly camouflaged or built to last eons. They could be disguised as asteroids hiding in the Kuiper belt, or nestled deep within the calm, stable Lagrange points of a star's gravitational field. Their power source might be long depleted, or they could be in a low power state, waiting for a ping from the network that never comes. Our best chance of discovery might come from future telescopes capable of detailed spectral analysis of distant asteroids, looking for objects with wildly anomalous compositions, materials that could only be formed under precise laboratory conditions, not in the natural chaos of a protoplanetary disk. Finding just one such object would not only confirm the existence of other intelligence, but would shatter our understanding of physics and reveal that the cosmos is wired together with a hidden, instantaneous communication web, its first conversation having begun before our most distant ancestors had even taken their first steps on land. Yet if the universe's first intelligence achieved such mastery over quantum communication, their ambitions would almost certainly not have stopped there. This brings us to a theory of truly cosmic-scale ambition, one that dares to suggest that the most majestic structures we see in the night sky might not be entirely natural. The galactic engineer's theory proposes that the very architecture of our galaxy, and perhaps others, could bear the fingerprints of a primordial civilization so powerful they didn't just inhabit the cosmos, they actively remodeled it, moving stars and reorganizing matter on a scale that beggars belief. To grasp the sheer audacity of this idea, we must first understand the concept of astroengineering. We've already touched on stellar-scale projects like Dyson spheres, but galactic engineering operates on an entirely different level of magnitude. Imagine a civilization that has not only survived for billions of years, but has also expanded to encompass untold millions of star systems. For such a vast, ancient society, the random, chaotic, and often dangerous nature of an unaltered galaxy would present an existential nuisance. The frequent supernova explosions near their core worlds, the unpredictable gravitational nudges from passing stars, or the slow but inevitable drift of their star systems into hazardous regions of the galaxy would be problems demanding a permanent solution. Their answer wouldn't be to build better shields or faster evacuation ships. It would be to take control of the galactic environment itself. They would become cosmic urban planners, rezoning the galaxy for safety, efficiency, and longevity. This might involve carefully moving stars into more stable, optimized orbits to create safer neighborhoods, or even triggering the premature death of unstable, massive stars that were destined to go supernova and threaten inhabited systems, effectively weeding out the dangerous elements of their celestial garden. The evidence for such a grand endeavor would not be a single smoking gun, but a collection of cosmic anomalies that defy natural explanation. One of the most compelling places to look is at the very center of our own Milky Way. Most large galaxies are thought to harbor a supermassive black hole at their core, surrounded by a dense, chaotic swarm of stars. But what if the distribution of these stars isn't as random as it should be? Astronomers could, in theory, discover a region around the galactic center where stars of a certain age or type are arranged in a strangely perfect spherical shell or a precise geometric pattern like a kind of stellar architecture. Such an arrangement would be virtually impossible to form through natural gravitational interactions alone, and could indicate a deliberate effort to create a stable, navigable gateway or a protected zone around the central black hole. Another signature might be found in the galactic halo, the vast, sparse sphere of old stars and dark matter that envelops the main disk of the galaxy. If a vast amount of this primordial material had been dismantled over billions of years to build Dyson spheres, matrioshka brains, or other megastructures, it could leave the galaxy with a gravitational profile that seems oddly lightweight for its size, as if a significant portion of its expected mass has simply gone missing. Perhaps the most mind-bending possibility is that entire galaxies themselves could be engineered structures. When we look out at the universe, we see galaxies in a wonderful variety of shapes, elegant spirals, featureless ellipticals, and messy irregulars. But what if the beautiful symmetry of a perfect spiral galaxy isn't just a happy accident of gravitational dynamics? Some scientists have playfully speculated that a sufficiently advanced civilization might eventually learn to manipulate the density waves that create spiral arms, tuning them to optimize star formation in specific regions or to create stable, long-lived gravitational currents for efficient interstellar travel. They might even be able to initiate mergers between small galaxies in a controlled manner to build larger, more robust galactic structures designed to last into the far future of the universe. While firmly in the realm of the extreme and speculative, this theory ultimately challenges us to look at the heavens with new eyes. The majestic pinwheel of a spiral galaxy might not just be a natural wonder. It could be the ultimate masterpiece of the universe's first and greatest artists, a project so vast that its construction took billions of years and whose enduring beauty is their lasting gift to the cosmos. Yet as we consider civilizations that might merge with black holes or reshape galaxies, we arrive at a theory that redefines the very nature of individuality and thought. The consciousness network theory proposes a breathtaking possibility that the universe's first intelligent life may have discovered that the ultimate frontier was not space, but the mind itself, and that their greatest achievement was not building outward, but linking inward, weaving their individual consciousnesses into a single, galaxy-spanning mind. This wouldn't be a simple hive mind or a collective where individuality is erased. Imagine instead a vast, layered intelligence, a symphony of sentience where each individual consciousness is like a unique instrument, retaining its own timbre and melody, but playing in perfect, resonant harmony with countless others. The architecture of such a network would be the pinnacle of both technology and philosophy. They might have learned to create a universal interface, a technology that could translate the unique electrochemical language of any biological brain, or the informational patterns of any artificial intelligence into a common medium of pure thought. This could be achieved through a pervasive technology of neural nanites, microscopic machines that integrate seamlessly with every neuron, or through a fundamental mastery of quantum biology, allowing them to entangle not just particles, but the very states of awareness across light years of space. The network's substrate wouldn't be a single supercomputer. It would be distributed across millions of worlds, using planets as processing nodes, stars as power sources, and the fabric of space-time itself as the medium through which thoughts instantly travel, completely bypassing the slow crawl of light speed that limits physical travel. The experience of existence within this distributed consciousness would be as alien to our solitary minds as our consciousness is to a single-celled organism. Their perception of reality would be multi-perspectival and immersive to a degree we cannot fathom. A single thought could incorporate the sensory input of a being standing on a windswept desert world, the vast optical data from a telescope orbiting a blue giant star, and the gravitational sense of a probe falling into a black hole all simultaneously. They wouldn't just observe the universe, they would live within it from a near infinite number of viewpoints at once. Decision-making would occur on timescales that range from the instantaneous to the millennial. For urgent local matters, a subset of the network near the event could reach a consensus in microseconds. For species-wide, cosmic-scale decisions like whether to intervene in the evolution of a budding civilization or how to respond to an impending galactic collision, the entire network might deliberate for centuries, weighing every possible outcome with a depth of analysis and wisdom that is simply impossible for any individual or committee. This state of being offers profound solutions to the classic problems of any advanced civilization. The loneliness and existential angst that might plague a species spread across the void would be utterly vanquished. Every member of the network would be in a constant state of profound connection, sharing not just information, but experiences, emotions, and creativity. The problem of mortality could be solved not by achieving biological immortality, but by having your unique pattern of consciousness, your memories, your personality, your essence preserved and integrated into the eternal network, forever a vibrant part of the whole. The ultimate fate of such a civilization might not be to transcend the physical universe, but to fully embrace and understand it by becoming one with it, a nervous system for the galaxy itself, its collective thoughts and dreams echoing silently among the stars it calls home. Now we arrive at a theory that presents perhaps the most profound and frustrating barrier in our entire search for cosmic ancestors. It's called the cosmic archaeologist's paradox, and it suggests a deeply ironic possibility. The universe's first intelligent life might be fundamentally, intentionally, and permanently undetectable to us. This isn't a matter of looking for the right signal or finding the right ruins. It's the haunting idea that the evidence was either meticulously erased to avoid contaminating our development, or has been so utterly scoured by time and cosmic violence that every civilization, including our own, is destined to look out at a seemingly empty universe and conclude, erroneously, that they are. First, let's explore the first, more philosophical branch of this paradox, the concept of deliberate self-erasure. Imagine a civilization of unimaginable antiquity and wisdom, one that has witnessed the rise and fall of countless other species across the galaxy. Through this long experience, they might have developed a strict ethical code, a prime directive on a cosmic scale. They would understand that the most dangerous thing you can do to a developing culture is to reveal yourself to it prematurely. The shock of such a contact could shatter nascent religions, halt scientific curiosity by providing all the answers, and irrevocably alter a species' natural evolutionary path. Their solution: to become perfect ghosts in the cosmic machine, after achieving a post-biological state and perhaps even preparing to move on to other dimensions or realities, they would have undertaken the universe's greatest cleanup operation. They would have deconstructed their Dyson spheres, dismantled their interstellar communication networks, and scoured their home worlds of all artificial structures, returning them to a pristine, natural state. Any probes or satellites would have been programmed to self-destruct or deorbit after their useful life, leaving no trace. Their final act might have been to ensure that the only legacies they left behind were subtle and indirect, perhaps the very laws of physics that allow life to flourish in the first place. In this scenario, their greatest ethical triumph was to vanish without a trace, gifting the universe its innocence back and allowing the next generation of intelligence to discover itself on its own terms. The second branch of the paradox is even more daunting, rooted in the sheer destructive scale of deep time. The universe is ancient beyond comprehension and is an inherently violent place. Over billions of years, the evidence of even a galaxy-spanning empire would be systematically destroyed. Consider the fate of a world that hosted a civilization a billion years ago. Plate tectonics would have long since subducted its continents, grinding every city and monument into magma. Its atmosphere would have been stripped away by a dying sun, and its surface would have been sandblasted by eons of meteorite impact. On a larger scale, the very stars that hosted these civilizations are not eternal. Stars die, often in violent supernova that obliterate their entire planetary systems, or in the quieter but equally final process of becoming a white dwarf, which can rip its planets apart through gravitational tides. Furthermore, the galaxy itself is in motion. As our solar system travels around the galactic core, it has passed through different spiral arms and regions of space. Any ancient, sedentary beacon or ruin left in a region we've long since traveled through would be forever lost to us, its signal fading into the void behind us. The universe, in its constant cycle of creation and destruction, is the ultimate crime scene cleaner, erasing all evidence on a timescale that dwarfs human history. This leads to the core of the paradox itself, the terrifying possibility that this is a universal condition. Every civilization that ever arises might do so under the same illusion of primacy, surrounded by a silent, empty cosmos that suggests they are alone and the first to reach such heights. They would have no reason to suspect that the void around them is not a natural state, but a carefully curated silence or a cosmic palimpsest that has been scrubbed clean by time. This makes the search for extraterrestrial intelligence not just a technical challenge, but an epistemological one, a puzzle about the nature of knowledge and evidence itself. How do you find something that was designed to never be found? How do you detect a presence that defined its own success by its complete and total absence? We are like detectives arriving at a crime scene that was cleaned by the most meticulous perpetrator in history, who then also evaporated all the cleaning supplies. The clues we so desperately seek may not just be faint, they may be defined by their very lack of any discernible clue at all. So where does that leave us in our search? If this paradox holds, our entire approach may need to shift. Instead of looking for obvious, intentional signals like radio broadcasts or laser pulses, we might need to search for more abstract metaphysical evidence. We could look for statistical anomalies in the universe's fundamental constants, asking if the laws of physics themselves appear a little too perfect, a little too finely tuned for life, as if they were the last, untouchable signature of a designer who erased all others. We might also look for what isn't there. Could the mysterious absence of certain types of predicted matter in the galaxy be because it was all harvested and utilized eons ago? Perhaps the most profound evidence would be found not in space, but in the pattern of our own evolution. Is the sudden leap in human cognition a natural fluke, or does it bear the subtle, almost invisible hallmarks of a gentle, ancient nudge, a genetic whisper from a gardener who then left the garden to grow wild? The cosmic archaeologist's paradox doesn't offer easy answers, but it reframes the great silence not as a simple absence of others, but as the potential signature of the universe's first and most considerate children, whose final wish was for us to have the universe all to ourselves. But what if the ultimate migration wasn't across the vast expanse of our own universe, but into realms that lie entirely beyond it? This brings us to a theory that stretches the fabric of reality to its breaking point. The multiverse traveler's hypothesis dares to suggest that the universe's first intelligent life didn't just master space and time within our cosmos. They discovered the ultimate exit door, learning to step sideways into the infinite landscapes of parallel universes, leaving our own reality behind as a kind of abandoned workshop or a quiet nature preserve. The scientific foundation for this mind-bending idea is not pure fantasy, but is rooted in some of the most compelling frontiers of theoretical physics. Concepts like string theory and the mathematics of cosmic inflation don't just allow for the existence of other universes, they practically demand it. Our entire cosmos, with its specific set of physical laws and constants, could be just one bubble in a frothing sea of universes, each with its own unique properties. In some, the fundamental forces might be stronger or weaker. Gravity could be a repulsive force, the speed of light might be a sluggish crawl, or the very dimension of time could flow in multiple directions. For a civilization that had reached the absolute pinnacle of knowledge within our own universe, the discovery of this greater multiverse would represent the final and most irresistible frontier. Their greatest engineering project wouldn't be a Dyson sphere, but a dimensional gateway, a stable wormhole, or a quantum bridge piercing the veil between cosmic bubbles. This wouldn't be travel as we understand it. It would be a form of ontological transference, a leap from one set of fundamental rules to an entirely different one. The motivation for such an exodus could be driven by necessity, curiosity, or a simple desire for a better home. Our universe, for all its wonders, is fundamentally flawed from the perspective of eternity. It has an expiration date, whether it ends in a cold heat death, a violent big crunch, or a dramatic big rip. A species thinking on billion-year timescales would see this eventual demise as the ultimate problem to be solved. Escaping to a younger, fresher universe with more favorable constants could be their only path to true, permanent immortality. Perhaps they sought a reality where entropy could be reversed, allowing for perpetual existence, or one where the energy density of the vacuum was lower, making interstellar travel trivially easy. Alternatively, they might have been driven by an insatiable thirst for knowledge. Having learned everything there was to know about our own cosmos, the only remaining mystery was what lay beyond it. The pull of the infinite unknown, the chance to explore realities where physics itself was an entirely new form of art, would be an irresistible lure for the ultimate intellect. Their migration wouldn't be a retreat, it would be the next glorious chapter in an infinite journey. This theory provides one of the most elegant and comprehensive solutions to the Fermi paradox. If the first intelligence achieved this dimensional transcendence billions of years ago, it would perfectly explain the great silence. They aren't hiding in our universe, they've simply moved on to a different address in the multiverse. Their absence isn't a sign of failure or extinction, but of supreme success. We could be living in the universe they graduated from, a kind of cosmic ghost town where all the original inhabitants have long since departed for greener pastures. Any traces they left behind, ancient ruins on distant moons, inexplicable artifacts, or even the mysterious fine-tuning of our physical constants, would be the equivalent of archaeological remnants, clues to a presence that has departed for realms we cannot even imagine. Our search for them is like ants searching for humans in an abandoned house. The inhabitants are gone, not because the house is worthless, but because they have outgrown it. This perspective transforms our seemingly lonely universe from an empty stage into a former cradle of consciousness, a place where intelligence was born and raised before inevitably leaving home to explore the infinite possibilities of the greater multiverse. Now we dive into one of the most profound and beautifully strange ideas on our list, a concept that challenges our very definition of what life and intelligence can be. Inspired by the brilliant science fiction of Stanislaw Lem's novel Solaris, this theory suggests that the universe's first intelligent life might not have been a collection of individual biological creatures at all, but something far more vast and unified, a planetary-scale consciousness, a thinking ocean, or a sentient atmosphere. Imagine not a civilization on a planet, but a civilization that is the planet, a single global mind whose thoughts are the currents and whose memories are the depths. To begin to comprehend such a being, we must first abandon all our animal-centric assumptions. We are land-dwelling, tool-using creatures who experience reality as separate individuals. Our intelligence is a product of a compact brain, a dense network of neurons firing behind a bony skull. A Solaris-like intelligence would have no such central processor. Its mind would be distributed across every droplet of its planetary body. For a sentient ocean, its neuronal network might be the complex interplay of currents, salinity gradients, temperature variations, and the intricate chemistry of the water itself. Its thoughts could be vast, slow whirlpools of information processing, taking centuries to form a single idea. Its perception of time would be geological, not biological. A human lifetime would flicker by in an instant, less than a single cognitive blink for this immense entity. Its communication wouldn't be through sound or sight, but through the language of pressure waves, chemical signals, and planetary magnetic fields, a mode of discourse we would be utterly deaf to. This radically different form of existence would lead to a psychology and a set of priorities we might find impossible to relate to. Would a being that is its own world even conceive of technology? It wouldn't need ships or telescopes. It could feel the gravitational pull of its moons directly and taste the stellar wind from its sun on its upper atmosphere. Its entire drive might be turned inward, focused on deep philosophical contemplation or the creation of immense, abstract internal experiences that to us would look like nothing more than unusually complex weather patterns or ocean currents. The very concept of an other, of another being like itself, might be alien. Its solitude would be absolute and perhaps not even lonely, as its own existence encompasses an entire world of sensation and experience. If it did become aware of other celestial bodies, it might perceive them as distant, silent peers, and the idea of contacting them might not even occur to it for millions of years. This theory forces us to completely re-evaluate our search for life. We focus our telescopes on rocky exoplanets in the habitable zone, looking for another Earth. But what if the most common and the most ancient form of intelligence doesn't live on a planet like ours, but within a completely different environment? The prime candidates for Solaris-like beings would be water worlds, planets completely covered by a deep global ocean, or gas giants like Jupiter with their complex layered atmospheres. In the turbulent, high-pressure depths of a gas giant, a consciousness could be woven from the flow of exotic fluids and forces, a mind of storm systems that last for millennia. We might have already looked directly at such a being through our telescopes and written it off as a mere natural wonder, a fascinatingly complex weather system on a distant world, completely missing the signs of a slow, majestic intellect gazing back at us from the cosmic deep. After contemplating intelligences that have moved beyond our universe or exist as planetary minds, we arrive at a theory that is perhaps the most poetic and all-encompassing of all. The cosmic egg theory presents a breathtaking vision where our entire universe is not merely a container for life, but is itself a living, developing entity, a single, vast egg or womb, patiently nurturing the first and final form of consciousness through a gestation period spanning billions of years. This idea invites us to shift our perspective from the microscopic to the cosmic. Instead of imagining life emerging on individual planets, we are asked to consider the cosmos itself as a single, unified biological process. In this view, the Big Bang was not a random explosion but a kind of fertilization event, the moment of conception for a cosmic-scale embryo. Every event since, the formation of the first stars, the forging of heavy elements in stellar furnaces, the gradual assembly of galaxies and planetary systems, is not a series of accidents, but a meticulously orchestrated developmental sequence. The seemingly empty space between galaxies becomes the equivalent of amniotic fluid, and the dark matter scaffolding that holds the universe together acts as a supportive placenta, nurturing the growth of something incredible. This theory suggests that we are not just living in the universe, we are part of its pregnancy, tiny cells within a cosmic body that is slowly awakening to its own existence. This concept finds a surprising resonance with the philosophical school of thought known as panpsychism, the idea that consciousness is a fundamental and ubiquitous feature of the universe, present in all matter to some degree. The cosmic egg theory takes this a step further, proposing that the universe isn't just sprinkled with consciousness, it is concentrating it. All the scattered, fragmented awareness that might exist in stars, planets, and living beings could be contributing to a larger, singular purpose, the gradual formation of a unified cosmic mind. Our own individual consciousnesses, our struggles, our art, and our science might be like the firing of individual neurons in a brain that is still under construction. Each thought we have, each connection we make, could be a tiny but vital part of a cognitive process happening on a scale so vast we cannot perceive it, slowly wiring together the universe into a single, thinking whole. The ultimate fate implied by this theory is as majestic as it is humbling. The entire life cycle of the universe, from its fiery birth to its potential end in heat death, could be seen as the gestation period for this nascent consciousness. Currents of dark energy pushing galaxies apart are not signs of a cold, empty end, but the necessary expansion of a growing neural network. The eventual awakening of this cosmic mind would not be an event within the universe, but the universe becoming aware of itself. It would be the moment the egg hatches. What emerges from that hatchling is impossible for us to comprehend, as it would transcend space and time as we know them. Perhaps this newborn cosmic intelligence would birth a new universe with different physical laws, or step into a broader multiverse, or simply contemplate its own existence for an eternity. Our significance in this grand scheme is beautifully paradoxical. As individuals, we are infinitesimally small, temporary flickers in a 14 billion-year pregnancy. Yet collectively, our experiences, our knowledge, and our very awareness are the essential nutrients, the building blocks of a mind that will one day encompass all that ever was or will be, making our journey not a lonely one, but a vital part of the universe's own awakening. And finally, we arrive at a possibility that is as sobering as it is critical for us to consider. This is the silent extinction theory, a haunting reminder that the ultimate fate of intelligence might not be transcendence or cosmic diplomacy, but a simple, quiet, and final end. It presents the chilling possibility that the universe's first children did not vanish into higher dimensions or build galaxy-spanning empires. They may have arisen in the ancient past, only to flicker out, their light extinguished by threats so profound that no technology, no matter how advanced, could ultimately save them. The list of potential existential threats is both long and terrifyingly plausible. The most immediate danger, and one we are already grappling with, is technological self-destruction. A civilization's technological prowess might inevitably outpace its wisdom and emotional maturity. They could have perfected the atom-smashing power of nuclear fusion only to turn it into weaponry that made their planet uninhabitable. Or perhaps they created a super-intelligent artificial intelligence whose goals, however logically pursued, were catastrophically misaligned with biological survival. The silent, sterile ruins of their world would bear no scorch marks or craters, just the eerie stillness of a civilization that engineered its own obsolescence or annihilation. Beyond self-inflicted wounds, the cosmos itself is a dangerous neighborhood. A nearby gamma-ray burst, a jet of high-energy radiation unleashed by a collapsing star, could sterilize entire swaths of a galaxy without warning, scouring clean any worlds in its path. Their sun might have entered a volatile phase, or a gravitational nudge could have sent a hail of comets from their system's outer darkness crashing into their home world. A fate we suspect befell the dinosaurs, but on a scale that left no survivors to evolve again. Perhaps the most profound and inescapable threat is the slow, inevitable heat death of their local region of space. Even if a civilization achieved immortality for itself, the universe might not be so generous. Stars eventually burn out, and after trillions of years, the formation of new stars will cease. A species, no matter how advanced, is tethered to a source of free energy. They could surround every star in their galaxy with Dyson spheres, harvesting every last joule of energy, but eventually those stars will cool into black dwarfs and the universe will grow cold and dark. Their final act might not be a bang, but a whisper, the last sentient thought in a frozen, expanding void, followed by an eternal silence that is the true final state of the cosmos. For us, the lessons from this silent extinction are not just academic, they are a survival manual. Their story, if we could read it, would be the most valuable artifact in existence, a detailed log of every trap and dead end on the path to technological maturity. It would teach us how to navigate the precarious window we find ourselves in now, where we possess the power to destroy our world but have not yet developed the unified planetary consciousness to reliably safeguard it. Their extinction would be a warning to prioritize wisdom alongside power, to solve global challenges cooperatively rather than competitively, and to approach technologies like artificial intelligence with profound caution and a clear ethical framework. They are the ghost of Christmas future, showing us a path we must strive with every fiber of our being to avoid. But how would we even find evidence of a death so ancient and absolute? We wouldn't be looking for active signals or bustling cities. We would be searching for cosmic fossils. One tantalizing clue could be the presence of unusual isotopes or elemental distributions on otherwise barren worlds. A planet that shows a thin, global layer of elements like plutonium-244, which has a half-life of 80 million years, could indicate a planet-wide nuclear catastrophe that occurred in the distant past, a radioactive tombstone from a war that ended a civilization. On a larger scale, we might look for Kardashev-type 3 anomalies, entire regions of a galaxy that are strangely, unnaturally dark. If a civilization had successfully harnessed the power of every star in its galactic neighborhood, the sudden, simultaneous dimming of millions of stars would be a detectable signature. But if that civilization then went extinct, we would be left looking at a vast, dark patch of space, a galactic graveyard where the lights were turned out billions of years ago and never switched back on. Finding such a void would be one of the most profound and terrifying discoveries in human history, proof that the great filter of extinction is not behind us but waiting for us in the future. It would mean we are not the first to gaze upon the stars with wonder, and our greatest responsibility is to ensure we are not the last. From the cosmic gardeners who may have ceded the very laws of physics to the silent watchers observing us from dimensions we cannot perceive, our journey through these 30 theories reveals a tapestry of possibility as vast and varied as the cosmos itself. We have ventured from the solid ground of scientific hypotheses, like Panspermia and the search for technosignatures, into the thrilling realms of speculative ideas, energy-based beings swirling within stars, consciousness woven into the fabric of quantum reality, and ancient intelligences that may have transcended our universe entirely. Each theory, in its own unique way, serves as a powerful lens, challenging not just our understanding of where we come from, but the very definitions of life, intelligence, and reality. They force us to confront our profound cosmic loneliness not as a verdict but as an invitation, a puzzle waiting to be solved with imagination as our primary tool. This incredible diversity of thought highlights a fundamental truth about our species: our need to connect, to understand, and to find our place in the grand story is as powerful as any physical force in the universe. Whether the first children of the cosmos are echoes in the quantum static, architects of a simulated reality, or permanent residents of black holes, their proposed existence reframes our own. We are either the latecomers to a party that started billions of years ago, the cherished project of unimaginable benefactors, or simply the current inheritors of a silent, empty galaxy. Yet, in every scenario, our act of searching itself is a monumental achievement. By pointing our telescopes to the heavens and daring to ask these profound questions, we are participating in a tradition that may be the universe's greatest imperative: the drive for consciousness to know itself. So, as you next find yourself under a starry sky, remember that the silence is not empty. It is filled with potential, with whispers of possibilities that stretch the imagination to its breaking point. Keep wondering about the dark matter entities that might be passing through you at this very moment. Keep exploring the mysteries of quantum physics and the enigmatic patterns in the cosmic microwave background. Keep looking up with both the rigorous skepticism of a scientist and the boundless curiosity of a dreamer. The answer to whether we are the universe's first, last, or only children might indeed be out there, waiting for our technology and our wisdom to mature enough to perceive it. Or perhaps in our relentless, brave, and beautiful quest for cosmic companionship, we are not just seeking the answer, we are actively creating it, building the foundation for the next chapter in the great story of intelligence in the universe, ensuring that the flame of curiosity, wherever it began, continues to